everyone, my name is Timothy Lee Grant, and today we are continuing our journey on the Neetcode path. So let's jump right into it and figure out which is the next problem that we're doing. So go to the little rocket. Come on. Here we go. So we're doing two-sum. All right. So let's go. Given an array of integers nums and an integer target, return the indices I and j such that nums of I plus nums of j equal to the target, and I does not equal j. Okay? You may assume that every input has exactly one pair of indices I and j that satisfy the condition. Return the answer with the smallest index first. Okay, so we have one array, nums, and we're trying to look at the elements within that array to see, hey, do you sum up to this target value? So we're given target as well. So let's just look at this example and try to figure out what's going on. So we're trying to get to 7. So we say 3 plus 4, okay. What does that equal? 7. Well, there we go. We already got it. So we have index 0 and index 1 as our output right here. And the lowest index is first, meaning the 0 right there. Okay, so let's look here, and we're trying to get sum to 10. So we say 4 and 5, well that's 9, so that doesn't work. Now we do 4 and 6, and we say, hey, that sums up to 10, so we can do 0 and 2, right there. Okay, number 3 is 5 and 5, bam, we have 10 already, and we're good. Okay, so the easiest way to do that is obviously just doing a double for loop. So you just look at this 4 and then look at this one and then that one, and then if you don't find it, then you move this pointer to over here, say here, and then you look here. Obviously that's of n squared, so that's probably not a very good solution. So one of the previous videos that I made a couple days ago, someone was saying that I always default back to sorting a list and seeing if I can find anything interesting or helpful about that. And it's true, like the saying is, when you have a hammer, everything looks like a nail, right? So you're constantly trying to use the tricks that you know. And I really, I'm trying to now think differently and say, maybe sorting, I should try to expand outside of my bounds of sorting, but man, I'm really thinking about sorting here. So let me think. I'm going to think about if sorting actually can help me. So how would that work? I would, if the array is in increasing order, okay, and I have 2 pointers, one pointer here and one pointer here, and I'm trying to sum them up to be 10. So 4 plus 5, I'm going to look here and say that it's 9, right? And now, what does that tell me? That tells me that there has to be some information about the relationship. If you have a sorted list, right? I know that moving my pointer up 1 index is going to cause the sum to increase, right? Yeah. Okay, so if the sum is, so what if I get over the target? I don't want to be going backwards, right? Like that doesn't make any sense. Um, and I also, the other thing that I'm thinking is like a binary search, but then now I have two separate pointers that have relationship to each other. So that's difficult. Um, hmm. So what if this was, okay, so I want this 5 and 6. So let's just say target is 11, right? So I'm going to do kind of like this. Copy that over like this. Target is 11. So I know that I want to return those two. So I'm going to start with one pointer here and one pointer here. And then I'm going to say, oh, okay, 4 plus 3, that's 7. That is too small. Okay. Do I want to move this pointer or this pointer? So if I move this pointer over and I get what? Now so this one stayed the same and then this one is here. So now I have 8. It's still too small. Man, I am not thinking of anything other than the brute force method. I guess let's just write the brute force method and then see if we can figure out an optimization. Let's just do the brute force. So for I in range, whatever, what is it, nums? Length of nums for j in range length of nums. So the starting condition is, that should be j right there. The starting condition should be I plus 1 up to length of nums, and then this one should be minus 1 because we're going to stop when our first pointer is here and our second pointer is there, right? So it should be stopping at, this one is the second to last and this one is at the last, but it always starts one before the first pointer, so I think that should work there. Now, if nums of I plus nums of j is equal to target. Return, does it want it in like a tuple, or how does it want the output? Return the answer with the smallest. Looks like it's a list, so a list of I and j, and I is always going to be smaller. So let's do that. What is this range is like that. Okay, cool. So that is obviously the bad way of doing things. Let's so time complexity of that is O of n squared, which when doing these problems, you know that you never want O of n squared. You always want like n log n is the good one. I really do feel like it has to be something to do with sorting. I know I say that a lot. I know that's my go-to, but I feel like if it's sorted, so 3 and 4, I don't know how. So I is equal to 0, j is equal to 1, okay. And now I want to increase them. While j is less than length of nums. And then in here I'm going to increase I and j somehow. So do something. And then at the end of this, I return I and j. Okay. What is the something? If nums of I plus nums of j is equal to target, return ij. Okay. Now do the same thing, like, so what happens if it is smaller? Okay, and what happens if it is, what happens if it's bigger, and what happens if it's smaller? Like, if this is too big, okay, we need to move our indices backwards somehow. All right, I think I failed. I can't get it. I have no, yeah, I don't know. We're gonna look at the solution, so. Python, yeah. Oh, that's brute force. Okay, cool. So sorting. What's he doing here? So creates a list for I in, and then enumerate. So he gets the index and the actual value, and then appends that as a sub list within this bigger list. So it's a list of lists here. And then a dot sort. Okay. So is he sorting the index by index, not by the actual number? Okay. Why? While I is less than j, I is less than j. I and j represent what? So I is 0 and j is starting at the end. Oh yeah, what if I had, hold on, let me just go back to here and stop looking at the answer for right now. What if I like, okay, what if instead of having an index here and an index here, I have one index here and one index here? Well then, if it's bigger, I need to move this index. If it's smaller, I need to move this index, right? So, I is equal to 0 and j is equal to length of nums. And length will return the actual number of elements, so I want the index, it to correspond to the index, so it's -1. Right, so like in this one, the length is going to be 1, 2, 3, 4, but I want j to be indexing this one, which is the third index. Okay. So now, while I is less than j, okay. So the reason that I'm doing this is because I is always going to be smaller, and as they're coming together, eventually they're going to either overlap, which that's not, we can't return where I and j are the same value. It said somewhere here, right here. I does not equal j, so we can't have that condition. So they have to be apart, and it doesn't make sense if I've already searched through all of here for them to overlap, because then we're going to be doing things kind of, we're just redoing what we just did. So while this is true, if I nums of I plus nums of j equals to target, then return, and I is always going to be smaller, j is going to be bigger. Okay. So now I need to check. So if this is the case, okay, like it's bigger, pass, okay, elif that. Okay, so what do we do if nums of I and nums of j is bigger than our target? Well, I need to move this one, the right side index, over by 1 here. Okay, because that's going to decrease the total sum. So j minus equals 1. All right, and then else if, because we want to either, so we just changed the value of j. We don't want to then go and calculate this sum again right here, right? So that's why I did the else if. Else if this is the case, then I needs to increase, right? And then we're going to come back up here and do this. Now I'm trying to think of the boundary conditions for this. So if I decrease j and come here, this is going to keep going until they are on top of each other. And because we're guaranteed that there's exactly one pair of I and j that satisfy the condition, I think it's okay to press submit. No. Wrong. Your output is nothing. If I just did like run. So both are saying that I don't have any output. Should come here, then here, then here, and then should do one more time. And I is, oh, I is going to be less than, yeah, obviously. Okay, well, not so obviously. Negatives. We didn't say that we can have negatives in here. This is that's okay, fine. Dang. Well, the negatives are starting from biggest. This is going smaller, right? Okay, so nums dot sorted. Okay. Okay. Oh, but it's not keeping track of the index, right? Oh, okay. No wonder he was doing it that weird way of like keeping track of indices. Okay, so uh, the way that he did it was he had like I can do, let's see, nums equals, no, sorted list is equal to here. Now for I j in enumerate nums my sorted list dot append. And what do I want to append? I want to append I and j. And I is going to be, I always forget which one is going to be which. Is this one going, for the enumerate function, is this one going to be the index, or is this one going to be the index? One of them is the index, one of them is the value. Well, I guess what we have to do is just play with it, figure out if, yeah, anyways. Let's just assume that this is the index right now, and then if that's not the case, I just swap them. That's fine, okay. So append I and j. And we do that for all of the numbers, okay? So now I is going to be the index. I don't want I don't want the first element to be the index. I want the value. I'm going to call that value index. So this is value and this is index. Okay, and then if it's actually the other way, we'll just swap those two. So value will be first and index will be second. Okay? So now we sort my sorted list. So we sort it, and I think it should sort by the first element. So now we have a list of lists where each list is sorted by the first indices like value. Okay? So now I can say if what do I want to do? This is going to be like my sorted list, right? So if my sorted list, I'm just going to copy and paste that. And I want the first element this I represents the And then I want the value, which is at the 0th index, right? So now this I and this j are now representing, so I have a list of lists, and now the I and j are saying which list within the list of lists that I'm looking at. And I want to take the first value of each of the lists within the list, right? So like the actual value. Oh, okay. So then I do the same thing here, right? So like my sorted list, okay. And I want the ith element, 0th element, ith and 0th, okay. Like this, and then we swap those. So if it's smaller, if this is smaller, we need to increase I. Okay. And now I don't want to return the actual indices based off of my sorted list. I want to return the second value. So I found the two sublists that contain the values that add to the target. I want to return each of those associated indices that I kept track of. But I can't guarantee which one's smaller and which one's bigger. So what I can do is I can do like this, return my sorted list of the ith list, and now I want the first element. So the 0th element is the value, the 1th element is the index, okay? That's that index. And then I do the same thing for the other index, okay? But I can't guarantee which one's bigger and which one's smaller. So I say this one is min, take the minimum and return the minimum. This one is max, so I get the max, okay? Let's see. Let's see if it works. We might need to have to swap those. Was it? Okay. Let's try it. Let's just swap it. See what we get. I'm out of coffee too. I'm just gonna print value. Okay, so print value. I want to see if it is the actual values or the index. So, okay, this one has a 6 right here. This one has a 6 in it, and there is no 6 in here, so I know that I'm printing So I know that actually this value, the first one is indexes. So it is like this. Value. And now I should get the 6. Right? Yeah. Okay. Your output was output, but the expected return type is a list of integers. Oh, wait, hold on. Yeah, I didn't use this min and max correctly. Okay, I think I know how I need to fix this. I didn't use the min and max correctly. This minimum, so I'm going to take the minimum of this and the jth one, right? So whichever one is the smaller. Now I want to take whichever one is bigger. This. Okay. I thought I was onto something. IJ. Okay. So if it equals the target, that should... Alright, back to here. Oh, he does the min-max thing too. So why do you need that end return if we're guaranteed to have an answer? Is that what's going on? So return nothing? Like, does that make sense? No. Okay. If I do like print my sorted list, let's run that and see. Three 0 4 1 5 2 6 3. Like that's what I'm expecting, man. Yo, what is going on? If this is too big, I need to decrease J. That's exactly what happened there, right? So if it's too small, we increase I. Yep. And then else we decrease J. Nah. I can't figure it out at all. Using, however, there's a small logical step. IJ. Oh, here, IJ. Okay. Ah, finally. Okay. There we go. That was a fun experience. I'm so glad I had this experience. This was great. This was wonderful. Awesome. Anyways, thank you guys so much for watching this video. If you liked it, subscribe. My name is Timothy Lee Grant, and I will see you guys in the next video. Bye.